Great. Well, thank you very much for everyone who's attending. There'll be a few more people joining us in the next few minutes, but we'll get going. Again, I'm Edward Nixon, a board member of Waterfront for All, and I'm pleased to welcome you this evening to our Waterfront for All speaker series number 6, focusing on the Don River and Central Waterfront water flow and treatment projects. We're pleased to have Lou Gironimo with us, General Manager for Toronto Water. And before I formally introduce him, I would like to proceed with our land acknowledgement. We acknowledge we are meeting on land that is traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, and the Haudenosaunee, and the Wendat peoples, and is now home to many First Nations, Inuit, and Métis peoples. We also acknowledge that Toronto is covered by Treaty 13 with the Mississaugas of the Credit First Nation. So one of the things we talked about, so again, let me before I formally go just to quickly go through Lou's bio, I'll just mention that, of course, for those, many of you know this, but for those of you who don't, Waterfront for All is, I think we're about 4, coming up to, we're sort of ready for JK. We're kind of 4-ish years old, formally as a formal organization, almost 4 years old. As an informal organization, we're probably almost ready for grade 1. And we are focused on, accessibility and protection and, a matter of preserving and enhancing the accessibility of our waterfront from the Rouge River to the Tobico Creek. Our formal voting members are organizations, community groups, neighborhood groups, sailing groups, etc. We're always welcoming more people. There are a number of ways to get involved. And our board members are elected at our annual general meeting, which will be coming up in a couple of months in 2022. And they either there are people, they have to be nominated by the member groups. They don't necessarily have to be a member of the member groups, but they have to be nominated by the member groups. And we try, and we are continuing our efforts to broaden our representation. Obviously, a lot of the action in the waterfront is in the central waterfront. And a lot of our membership and member groups are focused in that area, but we are, continuing to work and reach out to folks in the east and west ends of 416, and that's something. And one of the things I think we're all concerned about is the quality of our water, what comes in from the lake and what goes out to the lake. And we are thrilled to have Lou with us this evening. So Lou is, as I said, General Manager of Toronto Water, a division of the City of Toronto. Under his leadership, the 1,700 staff in the Toronto Water focus on providing quality water services, supplying drinking water, treating wastewater, and managing stormwater, essential for protecting public health, property, and the environment. The division serves 3.6 million residents and businesses in Toronto and also portions of York and Peel. And it has a 28.2 billion in infrastructure. Lou has a diverse background, both in private and public sectors and municipal sectors at multiple levels of government. Some organizations he has been involved with include the City of Hamilton, Ontario Clean Water Agency, and the Ontario Development Corporation. He's also worked for private engineering and land development companies during his career. And Lou has had extensive experience in managing municipal infrastructure and working on a variety of urban development issues. So it's a pleasure to have him with us this evening. As I prepare to, so here's how the evening's going to go. Lou is going to present his, and we're going to go through his slides and his talk. Feel free to comment talk to yourselves, talk to each other in the chat. We'll be looking for questions from the chat to pose later on in the evening. And when Lou has completed his presentation, we'll start our Q&A session with a couple of questions from both our board members. Ed Hoare, our chair, will lead off, and we're also pleased to have Mark Matson from Swim Drink Fish with us this evening, and he will be posing a question to Lou as well. And then we'll open it up from them, and again we'll take questions from the chat and read them out loud and have Lou respond to them. And again, thanks so much. And I will now bring up Lou's presentation. And we are going to spotlight. Okay. Oh. Oh, what? Okay. Lou, you're unmuted. We're ready to
There
go.
we go.
There we
Thank you,
go.
Ed.
Well, thanks for being with us this evening. Take it away.
Okay, thank you very much. I'm going to have to rely on you to change the slides for me, so I'll just give you a prompt when we need to move on.
I'll
But
do my
first of all,
best.
great, thank you. First of all, I just want to say thank you for inviting me and welcome to everyone, and hope you learn a lot about all the different projects that are going on within the city and how this will improve water quality throughout the city, particularly in the Inner Harbor and outside of Ashbridges Bay. But more importantly, the work that we're doing is foundational and sets the city up for success for at least the next 100 years or more. So if you go to the next slide, where did this all begin? It started off with a large wet weather flow master plan. That was the title to a document that we put together many years ago. And that document, just very much in keeping with what you described that Waterfront for All is about, where you're looking at the entire waterfront. The wet weather flow master plan looks at the entire waterfront, but also looks at all of the creeks and tributaries and waterways throughout the entire city. So it is an extensive document, and it identifies work in every part of our city. Tonight's presentation is going to focus on the Lower Don area. Now, the purpose of the wet weather flow was primarily to improve water quality for recreational use, for swimming, boating, fishing, to improve aquatic habitat, to reduce nutrient levels that are getting into our waterways, and to support the revitalization along Central Waterfront. It's also to address capacity issues. So as we're going along doing work, we need to be aware that our city continues to grow, and we need to service that future population. And it's also addressing some erosion and sediment issues, particularly in and around Ashbridges Bay. And we did that work jointly with the TRCA. The Toronto Water Capital Plan and Budget was just approved by Council in December. And so the new 10-year capital plan that Council approved is about just over $15 billion of work. And as you saw in the introduction, we deal with drinking water, wastewater, and stormwater. Tonight, I'm going to focus specifically on the stormwater components. In that $15 billion over the next 10 years, $4.1 billion has been allocated for stormwater management, with $1.83 billion going towards the wet weather flow master plan, and $2.27 billion being directed to the basement flooding protection program. So next slide. So the master plan, the original plan was adopted by Council in 2003. It was always intended to be a very long-term plan with a significant amount of work and significant investment required over the years. And it became a foundational document for all of our stormwater management programs throughout the city. It's designed to eliminate the discharges of combined sewer overflows. It was also at the beginning dealing with basement flooding, but at a much smaller level. With storms that we had in 2005, again in 2007 and 2009, and then subsequent to that, we had many more storms that flooded more homes. Council significantly expanded that component of the wet weather flow master plan, and that's why you see the number split between the wet weather flow projects and basement flooding. Now, the whole purpose of the wet weather flow master plan, and in particular, what we're going to focus on tonight, is as a component of that larger master plan, the Don River and Central Waterfront and connected projects. These projects are designed and are built out of an environmental assessment that we did in 2008 that we had focused specifically to try to get the Inner Harbor delisted as an area of concern, as identified back in 1987 with the International Joint Commission. We believe that once all the work is completed, the quality of the water at the Lower Don and in the Inner Harbor will allow us to apply for delisting. Next slide, please. So the series of projects that you're going to see tonight, it is the largest combined sewer overflow control project of its kind in Canada. It is the most significant water quality improvement project within the Wet Weather Flow Master Plan. It comprises a series of integrated tunnels, storage shafts, high rate treatment facilities, and other elements to keep combined sewer out of the Lower Don and Taylor Massey Creek and the Inner Harbor, and by capturing it and then conveying it over for treatment. It was always planned to be phased implementation because it's order of magnitude. Those series of projects are $3 billion, and it's funded by the city's water rate with some funding from development charges. But to date, we've not received any federal or provincial funding towards these projects, although we continue our dialogue with particularly the federal level of government. Next slide. Now, why do we keep talking to the senior levels of government? As I mentioned, the work that Toronto is proceeding with, and that we have earmarked and budget in the long run in our capital plan, is designed specifically to deal with priorities and initiatives that the federal government and the provincial government have identified many years over and over again. And these were in Government of Canada obligations that they have with the US under an intergovernmental agreement to improve Great Lakes water quality. And tied to that Canada-US Great Lakes agreement is an agreement signed by Canada and Ontario, because Ontario is the one that's the lead on helping do the work within the Great Lakes Basin, particularly Lake Ontario and Huron. We were successful in this iteration of the renewed Canada-Ontario agreement to at least get mention of these sets of projects in the document. No funding with it, but at least we got mention. And so you can look into that document on page 47 and see that the federal government and the provincial government agreed to continue to promote funding of these infrastructure projects to move towards delisting those areas for and having them removed off of the area of concern list. Next slide. So what are combined sewer overflows for some people who aren't familiar with it? They occur typically in older cities where one pipe is essentially conveying both sewage and stormwater when it rains heavily. And it's not all stormwater in our city, because we do have some road drainage systems that were put in place in the late 60s and 70s that handle some of the road runoff, but not all of it. Some of the foundation drains that buildings have still go into the sanitary sewers, and that causes a significant increase of flow when it's raining. Now, most of the time, that combined sewage flows into our treatment plants, and they get fully treated in Ashbridges Bay, and the Humber plant also has some flows. However, during periods of heavy rainfall, when we see significant amounts fall, the system was designed to overflow, and it does. If you think about it, kind of like a bathtub, the bathtub fills up, and the bathtub holds a significant volume of water. However, when you have too much water coming in too quickly, that bathtub starts to overtop, and that's what happens with these sewers. It was designed to act as a relief valve to protect property, so we don't have flooding in downtown properties and public spaces, and also to protect sewage treatment plants so they don't flood out and damage and get damaged during these extensive rainstorms. Next slide. So if we take a quick look at the sewer infrastructure, as I mentioned, combined sewers typically happen in the older parts of the city. And so we have 11,000 kilometers of sewer, but only about 1,500 kilometers are combined. 110 kilometers of storm sewers receiving combined sewer overflows during heavy rain. However, there are 310 locations spread throughout the city where the combined sewer overflow has regulators. And this is where the system has weirs or has been designed to overtop. And those are the black dots. So they occur deep within the system, and then they flow and combine into a single pipe, and they flow out towards tributaries. And that's where you see the red dots and triangles. Those are the outfalls. There's 90 of them across the city. As you can see, a lot of them concentrated in the lower Don and the inner harbor, some along Taylor Massey Creek, some along the Scarborough waterfront, and then a few along the Black Creek and Humber areas of our city. Next slide. So what are the impacts of combined sewer overflows? Well, the discharge contains nutrients and harmful bacteria and pathogens. They can contain some heavy metals, oils, pesticides, other contaminants that you typically find in domestic sewage. Combined sewers contribute to the degradation of surface water quality in the Don River and in Toronto's central waterfront. The nutrient enrichment causes harmful algae growth in parts of the shoreline and in the lower Don, and has an adverse impact on fisheries and the health of aquatic biota and their habitat. So other negative impacts is the aesthetics. It impacts recreational uses, and is not a pleasant thing for the revitalization efforts for Toronto central waterfront. Next slide. So how are we going about addressing this issue? So the wet weather flow master plan that I talked about essentially has two very large projects associated with it. First one is the Don River and Central Waterfront wet weather flow system, essentially 3 large tunnels, and I'll walk you through that. The second component is a landform project that we've done jointly with the Toronto Region Conservation Authority. It's to address some erosion issues by Ashbridges Bay, but it also will be the home of a future high-rate treatment facility that will treat the combined sewer overflows after we build the tunnels. In addition to that, there's other work that is underway because it's all part of the same system. And other environmental assessments that we completed at Ashbridges Bay led to the development of a new integrated pumping station that services not only the new combined sewer overflow that will come from these tunnels, but also will help us decommission the old pumping stations that right now are north of Lakeshore. Those will no longer be used in future, and it'll be integrated into this new pumping station. So it'll handle what we call dry weather flows when it's not raining, normal sewage, as well as the wet weather flow situation. There's also a new outfall pipe that's being built, larger capacity, better diffusion capability for improving discharge into Lake Ontario, and as well a new ultraviolet disinfection system being built, which will reduce effectively eliminate the use of the chlorine tanker cars that we have at Ashbridges Bay. We will still have to have some sodium hypochlorite if in case we have to do sodium secondary bypasses, but the primary source of disinfection in future will be ultraviolet disinfection. So we will significantly reduce the amount of chemicals we use before we discharge into Lake Ontario. Next slide. So if we take a look at the Don River and Central Waterfront and connected projects, so what area is it servicing within the city? It's essentially the central core, all the way up to Steeles Avenue. It services approximately 1.2 million people today. And we know that a lot of the high growth areas within the city are contained within this study area. So it will also handle continued population growth that we're seeing throughout this core. Next slide. So the specifics of the first set of large projects, the Don River and Central Waterfront wet weather flow tunnel system, is comprised essentially of 5 different stages. The red line you see is we call the Coxwell bypass. That project is underway right now and being constructed. It is about 11.5 kilometers in length. The total system will be 22 kilometers in length. Because that pipe, that tunnel, will continue with a smaller diameter tunnel that will work its way along Taylor-Massey Creek eventually, picking up additional combined sewer overflows. And then another more important one is the Inner Harbor West Tunnel, which will be built also in a subsequent phase. And it runs right across the Inner Harbor and connects at the western point to the existing Western Beaches system that we have in place and have been operating for the last 20 years. So ultimately, when constructed, we will have tunnels protecting combined sewer overflows and storm overflows stretching from Sunnyside Beach all the way over to the treatment plant. Those stars that you see, those are the locations where drop shafts will go in and pick up those overflows. If you remember that earlier slide where I talked about combined sewers eventually discharging into our tributaries, that's what those star locations are. We have to pick up that overflow and drop it down deeper into that tunnel. The tunnel is being built. If you go on the next slide, you're going to see some of the pictures that we've got underway with construction. So please advance another slide. So I talked about some of the benefits. It's going to eliminate the combined sewer overflows and stormwater runoff from the Lower Don, Taylor-Massey Creek, and the Inner Harbor, all leading to improved water quality, enhancing recreational uses such as swimming, boating, fishing, improving aquatic habitat for fish and other wildlife, reducing nutrient levels, everything that we talked about. These tunnels are intended to address all of those concerns, as well as improve capacity in the system to service future population growth. So if we go to the next slide, these tunnels are quite large, 6.3 meters in diameter. The Coxwell bypass in particular is interesting because and then the reason why it's called the Coxwell bypass, even though it's running through the Don River, it does connect at the top of the Coxwell sewer. The Coxwell sewer runs straight down by gravity from a location in the ravine into the treatment plant. That was put in service in 1960 and it cannot be taken out of service. We had to do an emergency repair on that sewer back in 2009, 2010. And it was quite expensive, cost us over $40 million to fix a segment of that sewer. To be able to continue to maintain that in future, you need to be able to bypass those flows and redirect those flows temporarily while you do maintenance work. Well, this combined sewer the combined sewer tunnel that we're building on the Don will act primarily as a combined sewer capture system, but it can also be used for us to bypass the Coxwell for a period of time, so we can isolate that sewer, get in there and do maintenance work, and then revert the flow back to the Coxwell sewer. So it's going to do dual duty. It's about 60% complete. It's about 50 meters deep as well. So that's what you are seeing in some of these pictures with the storage shaft looking straight down. This is one of the entry shafts that we have. And it runs about 50 meters all the way along. Next slide. So the Coxwell sanitary trunk sewer, that's the system that we will be able to bypass. Why is it so important? Well, it's the most critical sewer, sanitary sewer that we have in the city. It carries sewage for over 750,000 residents and businesses. As I mentioned, it has never been out of service, and you can't take it out of service until this bypass is built. The new tunnel will enable that redundancy to happen, and it will give us greater protection for the city on a go-forward basis. Next slide. Here is a picture of just that component of the Coxwell bypass tunnel with a schematic of the 5 larger shaft locations. As well, the tunnel is the blue, and then the stars are the locations where we will pick up the sewers right now that discharge into the river. So you have to think, if you could think 3-dimensionally here, the shaft, as you could see with the inset picture, It's quite large. The tunnel is right at the bottom of that, 50 meters deep. Those starred locations, those outfalls, primarily are at surface grade. So we do have to tunnel a much smaller shaft, smaller in diameter, but it has to go all the way down 50 meters and connect into that tunnel. So lots of complex tunneling work to be completed over the course of the next couple of years. Next slide. Here are some pictures of the tunnel boring machine that's in use, as well as when they were delivering it to the city for assembly. Next slide. Here's a shot of what was the preparation work in order to insert the tunnel boring machine down the shaft and then slide it back into this chamber, so you can then assemble all the pieces and it could then begin its work. Next slide. And this was the official launch. That is the cutting face of the tunnel boring machine, so you could see the size of the tunnel that's being constructed. Next slide. The Inner Harbor West Tunnel is a subsequent phase. We're in the preliminary design stage for those sets of projects. We have completed the EA, and we'll have 3 shaft locations. One at the Strawn Road area, where the Western Beaches tunnel ends, right by the Inukshuk. Another shaft location at a parking lot at Reese Street in Queens Quay, and then another twin shaft at Keating, right at the foot, at the mouth of the Don. This set of projects, because there's also interconnects that need to be built here, and that will pick up all of the overflows that typically you'll find in the various piers and quays along the Inner Harbor. This work, coupled with picking up all of the overflows in the Lower Don, are the key components of getting the city delisted off of as an area of concern. Next slide. So the Taylor Massey Creek component of it will be a smaller diameter tunnel. It does not need to be as large as the flows at this part of the city. Won't be as large as we have in the Inner Harbor and the Coxwell, but it's still important to pick up those combined sewers, as they do cause degradation within Taylor Massey Creek. So that also will be constructed in subsequent phases. Next slide. The second set of projects that's associated with the wet weather flow master plan is the Landform project and the high rate treatment facility. Just the Landform project alone is about $98 million of construction. As of August, this August, we were 38% complete. It is a joint initiative between the Toronto Region Conservation Authority and City of Toronto. It will improve erosion and sediment control to improve passage for boats in and around Ashbridges Bay, in particular the sailing clubs in that area. It eliminates the need for regular dredging of Coatsworth Cut, and we are going to be locating, well, as many of you can see the construction, it is located south of Ashbridges Bay. We had owned a water lot for many, many years there, so we were building it on that water lot, and it will house a new high rate treatment facility and stormwater wetland facility. We are in the early conceptual design stages for those 2 projects. We really have to build everything else, and those will be the final set of projects that go in. The high rate treatment facility, we don't have a cost estimate yet at this time, as we continue to look at different treatment technologies and are assessing their performance. We're looking at various systems across the globe to see if we can find the technologies that make sense for us to use in Toronto. Next slide. So here's a schematic of what we were going to construct. That we are constructing a lot of aquatic habitat improvements associated with the cells. These were designed closely with Toronto Region Conservation Authority, as well as Department of Fisheries at the federal level. So once completed, and there's the schematic drawing, and what you can see is the actual construction as of this summer. Those groins are starting to be formed, and it's going to provide excellent fishing areas for people in the city. Next slide. Now we get into a set of projects that are associated with the Ashbridges Bay treatment plant, but are integral to put in place all the protection we need for the wet weather flow projects. So the integrated pumping station that I referenced, most of you will not see much of it until we start building the structure above ground. There's lots of work going on in various phases. We're in the second phase. This work will be completed in 3 stages. And that third stage is when you will start to see a structure finally. And then you can see where it is, but it's located on the south side of Lakeshore, close to where you will see the water tower at Ashbridges Bay. It is quite a complex project. As I mentioned earlier, it's replacing 2 current pumping stations that presently exist north of Lakeshore. Many of you see those structures. One of them is a round building. Another one's a much older red brick structure. It was put in service in 1915. When we did assessments of the technologies that in place there, as well as the condition of those pumping stations, essentially the engineers told us they didn't know how we could refurbish those just the way they were constructed, primarily the older pumping station. So we needed to build a new pumping station, and it made sense to marry it up with the wet weather flow projects, hence the ingenious name of calling it an integrated pumping station, because it is addressing 2 different issues. So lesson learned, never let engineers name projects for you, because they're not too exciting. And the additional flows that we're going to get from Don River and Central Waterfront tunnel system will be received at this location. I'll show you a schematic of the pumping station. And as well, we are adding capacity for future population growth in these pumping stations. Next slide. So here's a drawing of where it's going to be located. If you take a look at this, I know it's a busy drawing, but I'll quickly walk you through it. The shaft location where you see launch shaft, the red dot, that is the present shaft for the Coxwell. So if you slide over to your right with the mouse, and it's the shaft that's just south of Lakeshore Boulevard, where Lakeshore Boulevard East, that's the shaft that's under construction right now. If you go just below that, there's a new building that will be constructed, and that new building is the white building. That is the new pumping station. It will take flows from all of the sewers that right now go to those 2 other gray pumping stations north of Lakeshore Boulevard within the park. That's the round building, as well as the older main treatment pumping station. Both of those buildings will be eventually decommissioned, and all the flows will go into the new pumping station. Next slide. So here's a 3D representation of what it looks like. And so this is why it's so complex. There is if you take a look at that screen building, that's the newer screen building, and underneath it, those 2 cylinders that you see, those are called the dry weather storage tanks. So most of the daily flow from sewage will go into those tanks, and we will pump those out and push them through into the treatment plant for treatment. Below that, you see 2 other deeper structures. Those are the wet weather flow pumping groups. those will handle the flows that come from the new shafts that we're building and the tunnels. Once we finally connect it all together, it will flow into those, and then we can decide whether we push that flow into the plant for treatment after the storm subsides, or eventually when we build a high rate treatment facility, we will be able to pump through a force main from this location, bypass all of the treatment plant, and put it in a high rate treatment facility south of the plant. The reason we can do that is most of the combined sewer overflows, when we analyze the strength of it, is essentially contaminated stormwater. It's very dilute sewage. And so pushing it through a treatment plant not only uses up capacity, but uses a lot of extra chemical and energy to treat this diluted stormwater or contaminated diluted sewage. This gives us the flexibility to decide which treatment technology we should use based on the strength of the sewage that we're dealing with. Next slide. The next key and large project to be built at Ashbridges Bay is a new outfall. The outfall essentially takes all of the treated flows out of the plant into Lake Ontario. This project is also underway and is about 40% complete. It's $279 million project. It will provide additional capacity and replace the existing outfall that was built in the 1950s. From a water quality perspective, it also is designed to improve the way it mixes in Lake Ontario. The existing outfall is under 1 kilometer away from the shore. The last 92 meters of it has the diffuser ports located at the bottom of the lake, and what you get is an interference with the mixing zone, as they call it, as the effluent mixes with Lake Ontario. You can get some interference along the shoreline or the near shore areas. The new outfall is much larger capacity. It's designed actually to match the inflow to the plant. Right now, the existing outfall does not match the total flow coming into the plant, and we have to bypass through another location called the seawall gate. We have to do what's called a secondary treatment bypass occasionally during heavy rainstorms. With the new outfall, we should virtually eliminate that from happening in future. And so the new outfall is 3.5 kilometers in length, with 1 kilometer of diffuser ports, about 50 different risers located through that last kilometer. So there'll be no total phosphorus interference with the near shore area. As well, you will then see total phosphorus be below peak water quality level at key shoreline locations. Now, this is also a very large tunnel, 7 meters in diameter, and it is designed to be bored through bedrock. So if we go to the schematics on the next slide. So we take a quick look at this. There's a deep shaft that's constructed at the Ashbridges Bay site. The tunnel boring machine is working its way out towards the location of the risers. The risers were put in place over the course of the last couple of years using a barge system. So if you are boaters, you might have seen a barge configuration. It looked like it was drilling for oil out there. They weren't. They were drilling the risers into the ground and placing them in line and through the soil, the bottom of the lake bed, and into the bedrock to the depth just above the tunnel location. Next slide. So if we take a look at this schematic, here's a better representation. This shaft's a little deeper than the other shafts. This is about 80 meters down, all in bedrock. And as you can see, the risers will sit at the bottom of the lake bed. Okay. Next slide. So here's a photo of the barge system and drill rigs that were used put the risers in place. And here's a picture of some of the risers working their way down. Next slide. The final project is the disinfection system that essentially is located at the south end of the plant and just before that deep 80-meter shaft that I talked about that would go into the outfall. So before it goes into the new outfall, it will be treated in this new ultraviolet disinfection facility. It's also under construction, about 56% complete, about $214 million. So it provides reliable disinfection as part of the full wastewater treatment process without using additional chemicals. So chlorine tanker cars will no longer be used. They've been used for decades. We will not use that anymore. The design of the system is using a new generation ultraviolet lamp technology, which is much more energy efficient and requires less space than the original first generation or conventional UV lamps. As I mentioned earlier, the project still includes the use of sodium hypochlorite. Sodium hypochlorite is essentially a strong bleach disinfection and dechlorination system to deal with any excess flows in case that we need to bypass a portion of the plant during extreme storms. Next slide. So here's a quick look at the UV disinfection system. The ultraviolet bulbs will be placed in line and will disinfect the effluent as it flows through these channels. The control panels are above. We can lift those light bulbs out for cleaning and replacement and maintenance purposes. Next slide. Here's some pictures of that facility being constructed, as well as artist rendering of it being fully completed. So new building to be located at the south end of our treatment plant. Next slide. So all of those projects, why are we doing this? Why are we spending all this money? Well, it's going to provide multiple long-term benefits for the city. It does work towards delisting, as I mentioned. So it keeps combined sewer overflows and stormwater runoff out of the Don River, Taylor Massey Creek, and along Toronto's Inner Harbor. It upgrades technology and capacity to pump stormwater and sewage for treatment. It upgrades the capacity for and the location that treated wastewater is discharged, especially important during heavy rainstorm events, and provides erosion and sediment control near Ashbridges Bay. It replaces the current chlorine gas disinfection system with a new technologically advanced ultraviolet disinfection system, and it improves beach water quality, which will lead to, hopefully, to the continued Blue Flag program and further improvement of some of the city beaches in and around that area. Okay, that's the presentation.
So before we get into our lead off, just if you don't mind, Ed, I just was very curious about one thing. And you said fishing with that Ashbridges Bay work. Am I correct in thinking, Lou, that when that's all done, that people will be able to walk around the exterior perimeter there? It will provide new access to the lake front?
So yeah. So part of the work that we've been doing is looking at how do we connect it to the Tommy Thompson Park area, because the new landform is built right beside that location, and so ultimately we do want to provide some path areas for people to walk on the extreme, essentially along the shoreline. We need to keep people out of the treatment plant area, of course, But the way we had designed this was to try to create some public access areas along the shoreline area first. Ultimately, depending on who else is involved and who wants to do more, by building what we built, you get much closer also to the eastern side of Ashbridges Bay. So one could conceptually look at someone coming along now, and it would be a lot cheaper now if you wanted to connect through a bridge crossing over Coatsworth Cut. But it's not part of this project. We are going to just focus on the water lot area where we are right now.
Thank you. It's my pleasure to introduce Ed Hoare to all of you who don't know Ed. Ed is the chair of Waterfront for All, and it's thrilling to have you here with us once again, Ed, for our sixth speaker series. I suspect you may have a question or two you'd like to sort of help lead us off with Lou.
Sure.
For Lou.
That was really interesting, Lou. Thanks so much. I'm a kayaker. I'm out on the water all the time. I've poked around the outfall construction. Probably not really supposed to be there, I'm sure, and have kind of followed, bits and pieces of all of this. And it's really fascinating to hear you pull it all together. And I guess my question would be this: I grew up in Toronto. When I sometimes talk to people and I say kayak on the harbor, and they go, "Oh my God, don't your arms fall off? Doesn't your flesh eat away?" And I say, "Well, not really. The water's really, kind of okay, except after a rainfall. And there's maybe times when you shouldn't be out there, but by and large, it's okay. I seem to be still here after years of poking around and rolling in the water and being in the water all the time. There's the beach system that we all know and love and are kind of used to now. But it would be my understanding that it would be a bad idea to be probably swimming in the Central Harbor, and certainly, things like the Keating Channel and other places are pretty obviously yucky most of the time.
You need to.
I guess my question is this: what should our expectations be? Should people be able to dive off the seawall anywhere near the Malting Towers or Keating Channel anywhere and be okay? Or what is reasonable to expect from all of this great work you're doing?
So there's a couple things you have to look at when you're trying to address water quality issues. One is the continued discharge. What's going in it on a periodic basis? So that's the combined sewer overflow issues. So that's why you see degradation happen after rainstorm, because you get that nutrient loading coming from that overflow that I was talking about. So that's what we're trying to address. In some locations, you also have to be worried about any old sediments that might have collected over the decades of contamination from other uses that might occur. And that can happen in some water locations. In particular, you might see some of that right at the mouth of the Don and the Keating Channel area. So, dredging and cleaning that up is also something that would have to be looked at. But a lot of that work is happening right now with all the floodplain work that's going on with Waterfront Toronto and TRCA. So huge improvements will occur as they fix the mouth of the Don. So now, from a water quality perspective, when all of this is in place, you will see significant improvements to the water quality throughout this area that's protected. Now, we've seen that already because we do measure water quality periodically as part of the wet weather flow master plan. We do a monitoring program with the Toronto Region Conservation Authority. And in fact, just was in an email conversation with John McKenzie, the head of TRCA, where they're going to start the next round of monitoring for wet weather flow. And what we do is we will monitor the water quality for a period of time and then compare it to the water quality that we had a few years ago. So over time, we've seen continued improvement, not only of water quality, but also fish habitat and aquatic growth. So improvements already happening. So that's why we believe once we deal with the continued overflow and we stop that component, we will see a continued and sustained improvement. And then you could start looking for specific individual problems if they still exist based on past uses and sediment issues. So
So
that's the longer term plan.
Would it be my
So you could jump in. My caveat as a city public employee, I would say to you, there's parts of the city where you should go in the water and other parts where you shouldn't go in the water, just to be safe.
Yeah. Would it be my understanding that it's my perception that there's been improvements through my life, that it's better than it was in 1965 or 1970
Yes.
by a
The
long
scientific evidence is there as well. So it's not just your perception. There is data to show improvement.
Okay, and so all of these parts that you've described, and they're amazingly complex and well thought out, and it would be my understanding that the improvements will continue to be gradual, or is it that you have to build the whole thing and then in something like 2038 you turn it all on and then there's a big improvement? Are we looking at a gradual improvement because of all this as we go?
Yes, you'll have to wait for it to be all turned on, because ultimately I can't receive all of those flows that we're picking up and lift it out of that pumping station. So the critical path item is that pumping station. Right. So that and it's also the most expensive. So if you were following the dollar signs, that pumping station is $660 million. That structure is replacing, as I said, the old ones, but is also doing the new wet weather flow. If I cannot lift that up and then treat it, then I will have to continue overflowing it. So I'm building all of this as I'm building the pumping station. Now the high rate treatment facility is something that we want, but we can start pushing through the treatment plant before that's finished. So we could start then taking flows from those tunnels once the pumping station's finished. So that's the critical path item, the one that we are keeping an eye on. And that's scheduled to go live and commissioning at about 2030, 2032. So that's the piece that's going to take a while to construct.
Okay.
Thanks.
Thank you.
Thank you, Ed. It's our pleasure to have our friend Mark Matson with us from Swim, Drink, Fish. And Mark, I think, has a question or two, perhaps two, for you, Lou, if that's okay.
Sure.
Mark,
yeah, that's fine.
I think you're turned on, Mark. I think if you want to say something, we'll find out if we can hear you.
Sure. Well,
there you are.
No, great. Thank you, Ed, and thank you, Ed. Really great for the invitation, everyone. I'm Mark Matson. I'm an environmental lawyer, a Lake Ontario waterkeeper and president of Swim, Drink, Fish, and we do some monitoring in the harbor, in the inner harbor. We post it on Swim Guide. You can see the data, and in some other areas we work with monitoring groups around the harbor. And just welcome, Lou. I know, you've been doing, I think Ed said, stunning and fabulous, and it's true. The direction of where Toronto's going with this project is incredible. I think the actual presentation was really great, and outlining some of the really urgent commitments that the city has made with the Canada-Ontario Agreement, the Great Lakes Water Quality Agreement, and for sure the United Nations Decade of Ecosystems, as the Great Lakes is the greatest freshwater ecosystem in the world. So we got a lot of responsibility. But I want to ask one thing, just because there's still a lot of time. I've been at this for 30 years. You pointed out 2003 goals are great, but there's this huge need, I think, within the Toronto water community for real-time monitoring and more monitoring and real-time monitoring of the 90 outfalls that you identified, the CSOs, et cetera. Maybe not all of them up the Don, but certainly the ones that are impacting recreational water users in the inner harbor. And I just wanted to know if the city is thinking, over the next 10, 15 years, there's going to be a lot of people out there. If you could follow what the city of Kingston did. The city of Kingston's a rare city where they run the water utility and the gas utility. There's only a couple of them in the province, Kitchener and Kingston. And so they knew a lot about tracking things because they track natural gas. So they started tracking CSOs and sewers and stormwater, and they have a real-time monitoring site. It's called Know Before You Go. utilitieskingston.com, and it's this really great real-time monitoring map of all discharges and overflows. So any of the users, for example, Ed, who mentioned kayaking, we're going to get it fixed at some time, but in the interim, keeping that pressure on and protecting the water users in the interim. Is there any, interest in increasing that sort of transparency around the current problems and sharing that with the rec water users? I hope that's clear.
Yeah, no, it's very clear. And it's an issue that we've looked at many, many times throughout the decade or more that we've been through the environmental assessment. The challenges that we have are very, very different than what you see in Kingston and other cities, just the way the sewer system was built. So of course, there are some locations that you can do some monitoring of, and we will, and in our plans, in fact, are to improve the way we monitor not only outfall locations, but also sewer flows. We are slowly building within the city. Another thing that a lot of people don't know is sensors that we use for operational purposes and also data purposes. So slowly we're building a smarter network of sewer system. Right now we're focused on those areas where we're trying to protect properties first. And so we've got a couple hundred sensors out there that are collecting real live data, and we use them to see how the levels of the sewers are rising and dispatch crews earlier. Now, ultimately, we want to continue to grow that system. It's in our capital budget to keep growing our technology and seeing what's happening in our system. And so we will look at a few of the CSOs. Some of them are difficult to get at. They're submerged. Some of the outfalls are fully submerged. So and you get reverse flow. If the lake levels rise up, we get water that comes back up on some of these. So the online sensing capabilities and opportunities in some locations are very, very limited. The data wouldn't be great, but we do know there's some areas where we could get data. Our plan is to put them in those areas where it makes sense for us to use operationally, and then use that data to augment a model that we use right now. We've developed a sophisticated model that predicts the discharges from these CSOs based on rainfall events that occur within that year. And we calibrate that model. Having a few locations that have online sensors will give us the actual results of those locations and then improve the accuracy of the information we're getting. So the system, I would love to be able to do what Kingston did and provide data of that. That would help me immensely as an operator. But if you looked at that picture that I showed of where the CSO areas are, all those little black dots where all those regulators are buried deep in the system. Those are the areas where you would have to pick up flows, because we've got to be accurate, to be 100% accurate. So I know you didn't say that. I know you were saying you're looking at doing things to improve data. You can't just go to the outfalls. You have to, because some of those are married up with storm flows. Some of the discharge is only storm and not CSO. So it gets very, very complicated depending on whatever you're specifically measuring. If you want the CSO data, you can't get it in some locations. That's the unfortunate problem we have in the way they built the sewer system. But we can get better information for sure, and that is in our plan to go forward.
Well, that's great. Now, if you don't mind, Edward, just quick follow-up. I think that's great that you're moving in that direction, Lou. City of Toronto has maybe, we oversee 8,000 beaches on Swim Guide, but you have as good a water quality monitoring program at your beaches where you monitor every day, geometric means, you're out there following the standard operating procedures. It's really incredible.
I would say it's one of the best in the world, and the most stringent.
Yeah, and you put it up there for open access, so we're able to take the data and share it, and you share it. But But on the other hand, you know, and Swim Drake Fish does a lot of this data. We're out there doing the same where there aren't beaches, and we're really doing it to try and work with you to find problems, source them, but also really to understand the nature of the uses on the water. When you said put that information where it makes sense, I just want to make it clear that, you know, maybe it comes from groups like this, but there are a lot of people, and in the last year and a half, a lot more people than I've ever seen sailing, rowing, stand-up paddleboarding, surfing, swimming year-round. You know, it's not seasonal anymore. They're out there every day, even in the ice. And just that data around when there are overflows, which is a risk to public, you know, to get that information to people as soon as possible, like the weather, and to be really transparent, I think, and it's just my opinion, but I really feel like it helps Toronto Water achieve those goals that you set out for yourself, those high goals for the next.
Agree. And that's why one of the things we did, in the absence of having the accurate data, we do post notices after a rainstorm, and we make and we have notices that go out through 311, where we do tell people there was a rainstorm, be careful. And to your point, we have the data that shows that most of the locations, the water quality rebounds relatively quickly, as long as the storm wasn't that large. We have really 3 beaches that are problematic. It's the Sunnyside Beach, because it's right beside the Humber River. It's Marie Curtis Beach, which is by the Etobicoke Creek, and the Rouge Beach, which is at the mouth of the Rouge. Those are the 3 rivers that are, I would say, give us the most problems of having consistent water quality. And that's tied to the fact that they're receiving all of the flows from not only urban areas, but also we find, for example, in the Rouge, there's a large wetland at the mouth of the Rouge. And a lot of the E. coli we're picking up is geese, ducks, all kinds of waterfowl, which is a good thing for a marsh, but for swimming purposes poses a problem.
But the Inner Harbor, there's 9 big CSOs, a lot of people using it and voting. That's the rural area that you're protecting.
The Inner Harbor.
Yeah, that's where we're focused on, like
so
that.
So the Inner Harbor Tunnel is the one that I would love to accelerate. So if you ask me, what would you, if in a perfect world and you had all the money, what would you do next? I would be sinking a tunnel boring machine in the ground right now, tunneling that one as I'm doing the Don River one, in a perfect world. And that's the comments that I made to the federal government, that if they're really interested in accelerating a cleanup of this area of concern and improving water quality and I completely agree with you, there's more and more people using it and more people coming to use it. And so how do we accelerate that? I'm ready to go. I'm in detail or preliminary design. I would love to start accelerating construction of that component of the work. We just don't have the money alone as a city based on the water rate and finances that we have. So if we get partners from, if both levels of government want to join, we could shave 7-8 years off of improving our ability to clean this up faster.
Do I see an opportunity for political action there?
you got to do it first.
Like something that we might be able to help with, perhaps. I don't know. But,
yeah, because Lou can't advocate. He can talk and negotiate and discuss, but he actually isn't in a position to advocate the way people like ourselves and Mark and the people on this who are joined us this evening can. So I guess is polite and respectful advocacy going to help you, Lou, from citizens?
I think we have a common objective here, and that's to improve Lake Ontario. When I say common, I mean the senior levels of government, the residents that live down there, the visitors, as well as Toronto Water. So if we're all in agreement that we want this cleaned up, the question is how fast do you want to go? And so I would welcome everyone getting on board to go faster, because the plans are there. We've got the approvals. I need the funding in order to start the next phases of construction.
Well, this leads into a couple of questions we got. Well, one question that was earlier on from Andrew was about Sunnyside Beach and how will the projects you have underway over the next decade, will there be further improvements to the, as you mentioned, often rather tragic quality of water at Sunnyside?
So Sunnyside Beach, that particular beach itself is problematic because of the Humber River. So a Humber River, when you know its entire watershed, only 15% of it is within the city.
Right.
The remaining 85% of it stretches out the Peel and York region. So what comes down that river and into the city is a lot of urban and in some cases rural runoff. Within the city, we do know, if you again go back to that map I showed you where you have particular outfalls, there are some outfalls on Black Creek, and there's some outfalls in the Humber, particularly Old Weston area, that we're going to address and clean up. That will reduce some combined sewer overflow, so some nutrient loading. We also have an extensive outfall monitoring program that we run every summer, where we go out and look for what are called cross connections, where essentially mistakes that happen in their sewer systems or the connection of buildings, where people connected sanitary sewers to storm sewers. So everyone thinks, well, if you have a separated system, the storm system is clean. Well, stormwater alone is not clean. And on top of that, you could have problems where you have buildings incorrectly tied into a storm system. So it's discharging untreated raw all the time. And we found probably over the last 10, 12 years, 700-800 locations throughout the city where that has occurred. So errors happen over the decades. You get plumber connecting to the wrong one or a homeowner doing an improper connection. So we will always have that program in place. That program will keep an eye on those types of problems. So until we get those addressed, and until you figure out how to deal with urban runoff, because that urban runoff from roads and sidewalks and refuse that you have, oil, grit, heavy rainstorm, it ends up into our tributaries. That impacts Sunnyside. We did do a review, and we were looking at if we could build some kind of deflector arm that pushes the flow of the Humber River further out into the lake to protect Sunnyside. But the cost of building that was quite substantial, because the lake drops off pretty quickly there, and you would need a significant amount of stone in order to build up some kind of pier. Or we were considering doing a series of islands with essentially a submerged berm with just some promontories that could connect, and so it would be attractive, but it was quite expensive, so we had to park that idea for now.
Okay, great.
So Sunnyside will always be challenging, but the rest of the waterfront over towards the east, that's protected with those tunnel systems, we've seen significant improvement in water quality in that area. We're in a major refurbishment stage. Sorry, just
no, go ahead.
To give you an update. So we've been running that for 20 years. Like any other piece of technology and equipment, it requires maintenance. So we are in fact doing a lot of construction work. If you're driving along Lakeshore, you will see all kinds of construction at various shaft locations. We are doing a lot of work improving the weir systems, the sediment control systems. We've had to address, in fact, the high lake levels. The high lake levels that we had at Lake Ontario a few years back were actually causing the lake water to come back into those tunnels. So we've designed better flap gates so it will protect those tunnels. So all that work is underway now, and we will continue to improve the functionality of that system.
Well, great. So touching on a couple of things you said, I've got questions that kind of from the chat that connect to that. So just to clarify, Brian's asking, so the idea of having a separate, to your point about, runoff and stormwater not actually being clean. It may not be sewage per se, but it's not clean. So that's why you want to move towards combining things and treating all of it. Is that
only in the downtown core,
Right.
So for example, if we've got parts of the city where we do have separated systems, or on the fringes of the combined where we can separate, we will do that.
Okay.
However, we still need to construct facilities to treat the stormwater. So I'll give you
Right.
a perfect example. You know, I don't know if you know other parts of the city, but Earl Bales, it's a park.
Yep.
The huge pond that we built there with the largest stormwater facility in Canada, I believe. People think of it as a mini little lake in there, but it's a stormwater treatment facility. It's capturing that stormwater, treating it in these ponds before it gets released into the Don River. We built another one on Emery Creek out by Weston Road, south of Finch. If you drive along Lakeshore, one of the first sets that we built was a series of little ponds. One of them right where the cenotaph is by the Humber, by the bridge. That people think that's a natural little pond. Well, no, that was constructed by Toronto Water, and it's a stormwater pond. There's another feature between the Gardner and Lakeshore, also a pond. So we use that technology to treat stormwater. We let the sediments drop. We let the sunlight deal with pathogens, because sunlight will kill it before we discharge it back out. So that's the way we would prefer to treat stormwater. Unfortunately, in an urban area, land is very expensive and you can't find it. So I can't build these types of structures in certain locations, and you have to use these tunnel and treatment technologies instead.
Right. I know we've had some questions about fast tracking the work and eliminating CSOs in Black Creek, Mimico, Humber, and the West End. But I mean, and you've spoken to some of that. I mean, again, in terms of fast tracking, it's really money, isn't it? It's really just money, isn't it?
It very is. That's the comment I always make to our council, who will say, you know, they would like us to go faster on certain projects. It's a simple formula right now, the way we've set our financing. We're using the water rate. If you want to go faster, think of the water rate as an accelerator pedal. You want to go faster, the rate's got to go up more, because you got to generate the revenue. And this is something that our council's understood, and that's why they supported water rate increases for quite a number of years. We're at the point now where we're only at 3% increases, because we're generating a significant amount of money. So just as a quick primer on our budget, our total revenues for 2022 is forecasted to be about $1.44 billion, primarily from water rates, about $1.25 billion from water rates, the rest from other fees, etc. $975 million of that revenue stream goes directly towards our capital funding program. So 67% of the revenue generated pays for these capital programs. That has been built by City Council over a number of years. To go faster, you're either raising the rates or you're finding partners in senior levels of government who will also contribute towards these projects. We will keep our money in. It's not to displace our money. It's actually so we could accelerate projects and get work done.
Okay, thank you, Lou. I've got a couple of questions from a couple of different people about microplastics and microfibers.
Sure.
And now one suggestion was is it true that a significant or 90, like how much of that is dealt with by the treatment system?
So,
and how much is getting through?
Yeah, basically. So microplastics and microfibers, there's a lot of work going on worldwide looking at the impacts of them. The testing that's occurred on the systems that we have, both the drinking water system and then again the wastewater system. We capture the vast majority of those through our water filtration system. So as we clean the drinking water, and then as it goes through the wastewater treatment process, our system also pulls out quite a lot of it in the biosolids that we generate. Now, it doesn't capture 100% of it. You get to the very, very small fibers, tiny particles, because it breaks down into some particles break down to very, very, very small quantities, and they can work its way through these systems, but a significant amount of it is reduced and removed.
Right. Well, actually, now we got a question where someone said that it seems like the benefits of some of the projects appear. It seems to appear to a few people tonight that it only sort of goes to Ashbridges Bay, and I just, if you'll allow me,
Yeah,
I'm a recovering downtowner. For the last 6 years I've lived in Birchcliff. I'm just I'm at the bottom of Birchmount Road actually. I'm just
right.
but not quite falling off the edge. And one thing I've noticed, of course, in the last few years is things like BlogTO have discovered the Scarborough waterfront. We've also had the pleasure, Ed and I have had the pleasure of hosting several presentations with our friends at and your friends at the Conservation Authority on the Scarborough Waterfront project. But even and that, of course, running from Bluffers Park to the first phase from East Point Park to Bluffers Park, that will do a number of great things for erosion and what have you. But it will also, which of course is close to our hearts in a way, it will also increase access. But even without that, I've noticed over, partially you could say it's the pandemic, fewer people traveling, but the amount of people that are walking, trekking, walking down and enjoying the Scarborough waterfront has, certainly anecdotally, I have not actually commissioned a study, Lou, but anecdotally, it seems that it's increased vastly. And there is that fabulous beach, just west of East Point Park, but it's not, Mark, as you know, it's not an official beach. It's not, no one's doing daily monitoring there. And yet, people are going in there. Same with Guildwood, it seems to me, and again, I know this may be getting a little far out there. And again, I know money, but it seems to me that the Scarborough waterfront is going to have vastly more pressure on it from people wanting to use it, wanting to swim in the lake. I mean, I know I've swum off Guildwood in October. Because I'm crazy, but it was nice.
Yeah, no, but it's a valid point, and it's one that Toronto Water raised many years ago. There was a beaches plan that was put together back in I believe 2008, 2009. And so I'm dating myself how long I've been doing this. And so when we put that document together, we raised some questions in there saying, can and should the city look at opening other beaches as opposed to trying to deal with Mother Nature on those beaches that are at the mouths of rivers? Perhaps you could relocate the public access beach areas and move them to areas where we know the water quality is significantly better. What does that require, though? That it then means investment in money, to your point. You need to build the access trails, you need to have the lifeguard stations, you need the change rooms, you need all the amenities to make it an enjoyable beach area, right? And so that opportunity still remains, and it would be up to council and our Parks, Forestry and Recreation Division to decide whether it wants to create other newer beach areas, designated beach areas that will have the monitoring and the lifeguard protection. That is the thing that we have to be worried of as a municipality, right? We cannot protect the entire shoreline. And so we designate certain swimming areas. We do know from a recreational perspective that people will go out and use the entire shoreline. And we warn them that be careful doing that. But it doesn't mean you can't look at those things in future. You definitely can.
Right. Well, I mean, I was going to say, because of course, I mean, again, the Scarborough Waterfront project isn't going to it's going to take several years to happen, of course. But I mean, it seems to me that's going to increase that it will definitely at East Point, it's going to radically increase the ease of access. And there are outflows, of course, as you well know, Lou, there are outflows along the Scarborough coast. And
so that's the other piece
that's going to be a concern.
So that larger wet weather flow master plan that I talked about, as opposed to the 5 specific ones that I was talking about downtown. Now, that wet weather flow master plan has identified work that's required on some of the CSOs that discharge directly to Lake Ontario in that Scarborough area, plus some of the storm outfalls that exist. So that plan is dealing with those particular locations because the plan's all encompassing. The Don River Central Waterfront is a component of the plan, just happens to be the largest. We have the same thing going on in Etobicoke. the Etobicoke waterfront has a lot of storm water outfalls along the front of it. And we know that there's opportunities to build stormwater detention ponds along that area and rework those outfalls. That will significantly improve water quality at various locations in Etobicoke. That's in our plan as well. It's money and how fast can you go? So that they're all tied the same thing. So we have a long list of work to do. We only have so much money every year, and we have to apportion it to these projects.
Not Mark, not to take anything away, Mark, from your very valid concerns about the Inner Harbor.
No, I look at, I'm out in Scarborough too. It's what a beautiful waterfront out here. Nice to see it be monitored and a little bit more water literacy.
But not only the waterfront, like our work, because I have to protect all of the Toronto water infrastructure that's in our ravines and creeks. Because think of it, the way we designed our sewers and our water mains is we did go up through our ravines. And it makes sense for sewers because we try to use gravity as much as possible in order to reduce the cost of pumping everything. And so I've got to maintain that infrastructure. So as we go in and protect that infrastructure, we do a lot of work within tributaries to improve from an erosion perspective first to protect the infrastructure. But while we're doing that, we do a lot of improvements for fish habitat and aquatic habitat. So huge geomorphological studies that we've completed in Hiley Creek. We've got some going on in the Yellow Creek. And so at Black Creek, we've done some work, and we will continue to do that in conjunction with the Toronto Region Conservation Authority. So I'm not responsible for all of the tributaries. TRCA has certain component, but I have to protect our infrastructure. Whenever we do our work, we improve that particular segment of where we did our work. And so you're going to see that throughout the city as well. And that's part of the wet weather flow master plan, in addition to all of the stuff on the waterfront.
So Lou, so a couple of people have asked, when will we be able to like put our cup in the lake and just drink it?
Well, my comment to you there is from as a water professional.
Yes, sir.
Never should you drink raw water. Okay. And it doesn't matter where you're getting it from, because the concerns that you have with raw water, there's a reason why we have the treatment systems we do.
Right.
If you go back in time and you think of Giardia, that's naturally occurring through beavers and other mammals that will be in the water. They could cause some sickness and illness and death. Mm-hmm. So you've got to be aware of that. Raw water itself, in the past was, you go back hundreds of years, a lot of people didn't drink raw water. They either boiled it or they made beer and wine, and they were drinking a lot of that. There was a reason for that. So I caution everybody on that. You drink treated water.
I appreciate that. Well, I mean, of course, and you mentioned it before, those damn geese. I think of the Center Island beach. The Center Island beach is particularly because of the breakwaters there. And yes. In times that water, as you well know, could be, and as anyone, as Ed knows and other friends in the island know, that because of the physical construction of the human intervention there, that water, it can get literally full of geese guano, right? And if you do testing on it, a lot of the E. coli is coming from these geese. I know when I took my eldest boy there when he was little, I never let him go in Center Island. He always wanted to wait in. I go, no, we're going to go over to Wards. It'll be better. We're going to go to Wards. What if you had one thing that besides just, one takeaway that citizens could support your work, what would it be? How can people best support you?
So the key takeaway is to continue pushing us to go faster, right? So I have zero problems with the public's impatient that we should get on with doing our work. I have the same impatience. I like to get projects finished and move on to the next one. So having people aware of the projects we're working on, having them understand the benefits of them, having them advocate that they want them done sooner. I fully support that because it continues to show that there is interest from our residents and citizens to make these investments. They're not cheap investments, as you can see. They're costly, but they're necessary to, and I'm talking about the whole suite of things, from basement flooding to water quality improvements. They're very expensive. And so we really do need the public to understand the importance of them and to support them. Because if I've seen in other cities that if that interest wanes, it's very easy for politicians to no longer support these large expenditures. And there are many cities in the US that are struggling to make the types of improvements that we're doing in Toronto because the will from the public is not there. So that's the takeaway, is that keep yourself informed. And that's why I'm pleased you invited me. This is a group that loves to be informed, which is great. Stay current, because there's always updates going on, and be aware of that this city is transforming. We are slowly building things that sets the stage for huge improvements for the next 100 years or more.
Okay. Any final comments, Ed or Mark?
No, I'm just, thank you very much for the invite. Learned a lot. We're as impatient as everybody. Lots still to talk about, and I'm just thanks for everything you guys are doing at Waterfront for All, and great idea inviting Lou.
Oh, thank you, Mark. Ed, any closing thoughts?
Just a great thank you to Lou and Mark for coming, and I think that you've given us food for thought as a group of citizens who are interested in the waterfront as to how we can best maybe try to pull some levers and push some boulders around and maybe help out if we can. So we'll look into that and maybe talk further.
Appreciate that.
Thank you, Lou. It's been a pleasure having you. I appreciate it. And thanks again, Mark. Thanks, of course, Ed, our beloved chair. So we often get asked about recordings of these events, and we do try to eventually get these up. We have, I sent it around, waterfrontforall.ca. We have links on our website to some of the recordings of our past events. And my esteemed colleague, Ron Jenkins, and I will, kind of get towards doing these. Sometimes it requires a bit of editing, so we try to do that. And but we will get this up. I can't tell you exactly when, probably sometime in the next month or so.